All right, today we are diving into something truly wild. It's an object from another star system, and it is completely baffling scientists. It's called 3I/Atlas, and as we're about to see, it seems to be playing by a whole different set of rules.
I mean, just think about it. What if something from way out there, from another star, came speeding through our solar system, and it behaved in ways we just can't explain? Well, that's pretty much what we're facing with 3I/Atlas. This is a genuine cosmic detective story. And like any good mystery, this one has clues. 3 of them, to be exact. And each one seems more impossible than the last. We're talking a tail that points towards the sun, a bizarrely regular pulse, and chemistry that just, well, it defies all logic. So let's break down the evidence one clue at a time. First up, the most obvious, most visually striking thing about this object, it has a tail that appears to point directly at the sun, which, if you know anything about comets, is the exact opposite of how they're supposed to work. Now, this phenomenon isn't completely new. It has a name. It's called an anti-tail, and yeah, we've seen them before. They're usually just an optical illusion, a trick of perspective based on where Earth is in its orbit. But here's where it gets weird. We've been watching 3I/Atlas for months now, from different points in our orbit. If this was just a simple trick of the light, that anti-tail should have shifted or even disappeared by now. But it hasn't. It's stable, it's persistent. And that means the simple explanation, it just doesn't fly. So this has kicked off a major debate with 2 very different theories. The mainstream view is that, okay, it's still an optical illusion, but one caused by some really unusual, big, slow-moving dust particles. But then you have Harvard scientist Avi Loeb, and he's proposed something else entirely, that maybe we're not looking at one object, but a whole swarm of smaller fragments flying along with it. And this is where it gets really interesting. See, Loeb's idea wasn't just a guess. It was a mathematical model that made a very specific, very testable prediction. He calculated that this cloud of fragments would create a glow pointing towards the sun that measured exactly 0.7 arc minutes across. Now, an arc minute is tiny. To give you some scale, the full moon is about 30 arc minutes wide. So this is a super small but very precise prediction. So, the moment of truth comes. Astronomers check the images from November, and the sunward glow they measured was, you guessed it, almost exactly 0.7 arc minutes. The math from this wild theory matched what we were actually seeing. It was a perfect fit. But, and this is a huge but, there's a major catch. For Loeb's theory to be right, we should be able to see these fragments. And yet, our best high-resolution images show a nucleus that looks perfectly solid, completely intact. Scientists looked hard for any sign of it breaking up. And they found nothing. So clue number 1 is still a deep, deep puzzle. All right, let's turn to our second clue, which somehow only deepens the mystery. We're talking about a bizarrely precise pulse, beating like some kind of cosmic clock. Yes, scientists tracking this thing noticed it gets brighter and dimmer in this perfect rhythm every 16.16 hours. We're talking clockwork precision. It's actually the most precise periodic pattern we have ever measured in a comet. Now, the obvious answer is, okay, it's just spinning, right? But no, it's not that simple. The solid bit in the middle, the nucleus, is tiny. It accounts for less than 10% of the light we see. Over 90% of that light is coming from the coma. That's the big gas cloud around it. And the coma itself seems to be actively pulsing, like inflating and deflating with every single cycle. It's as if the whole gas cloud is breathing. Okay, so what could cause that? Well, the leading natural explanation is something called thermal cycling. The idea is pretty straightforward. There's a big pocket of ice on one side. When it faces the sun, the heat causes a burst of gas. Then, as the object rotates, that pocket turns away from the sun, the gas flow slows down, and the whole cycle repeats every 16 hours. It's a plausible theory. But again, Avi Loeb comes in and points out a really simple way to test this. If the sun's heat is the trigger, then that jet of gas should always be pointing towards the sun when it pulses, right? So if we ever see that jet pointing in other directions, well, that would mean some other unknown engine is driving this strange cosmic heartbeat. And that brings us to our third and final clue. And honestly, this one might be the weirdest of them all. The object's chemical makeup is like nothing we have ever seen before. So, using radio telescopes, scientists could actually measure the chemicals boiling off this thing. In a normal comet, you might see, say, 10 times more methanol than hydrogen cyanide. But with 3I/Atlas, that ratio is more like 100 to 1. That is just a wild, freakish anomaly. But the real shocker, the thing that made everyone's jaw drop, was when they mapped where these chemicals were coming from. Turns out, the methanol is almost all coming from the side facing the sun. And the hydrogen cyanide, that's coming from the side facing away from the sun. It's one object with two completely different chemical faces. It's completely unprecedented. As one scientist put it, it's literally as if someone took two totally different kinds of comets and just glued them together. We've never, ever seen an object where one entire hemisphere is dominated by one chemistry and the other by a totally different one. And this is a massive problem for our theories. Remember that 16-hour pulse? That means the object is constantly spinning. Over the billions of years this thing has been around, that rotation should have mixed all its chemicals together, like stirring cream into coffee. The fact that these two distinct chemical sides still exist is a profound, profound mystery. So, let's take a breath and put all three of these clues together. What are we actually dealing with here when we look at the whole case file for this interstellar visitor? What we have is a tail that points the wrong way and refuses to be a simple optical illusion. We have a massive clockwork pulse that isn't coming from the rock itself, but from the gas cloud around it. And we have a two-faced chemical body that just shouldn't be possible on a spinning object. Look, any one of these clues would make 3I Atlas a fascinating, must-study object, but all three of them together, they paint a picture of something that just doesn't fit our models. It genuinely forces us to question our basic understanding of how objects even form and behave in other star systems. So the final question we're all left with is, what exactly are we looking at? Is 3I Atlas just an incredible 1 in a billion cosmic fluke, a freak of nature from a distant star? Or could these impossible clues be pointing towards something else entirely? For now, the mystery remains unsolved.